G'day guys, and welcome back to my channel. I just wanted to have a quick video going over this capacitor kit. I got this off of AliExpress. I couldn't remember if it was Amazon or AliExpress or eBay. Got it off AliExpress. It's supposed to be a low ESR capacitor kit. If you look at them, they all say low ESR. Some of them have got the vent spelt wrong, like the Chong-X caps that say VEHT. These ones are the same. It's a mixture of Chong-X and some other brands in here, where they've actually spelt the vent correctly. Oh god, bloody Asians. Anyway, so this is where things get funny. Low ESR, right? 63 volts, 100 microfarads. Now here's an SI brand cap that I got from JCar. And just to be funny, here's just a normal 63 volt, 100 microfarad cap, not low ESR, right? Now, just so you can see more of a difference, I'll go up to 1 kilohertz because I'll start at 120 hertz. Now, this is the AliExpress special. Almost an ohm at 120 hertz. Okay, let's have a look at just a normal capacitor. Same value, same voltage rating, just, you know, not advertised as low ESR. 0.4 of an ohm. That's very interesting. I will say these are really good caps. They're almost as good as low ESR caps. You go up in frequency, you're going to see the difference more. So basically the same down there. Like I said, let's go up in frequency. Let's go up to 1 kilohertz, right? There we go, 0.13 ohms at 1 kilohertz. Normal cap, almost 0.30. What do you reckon this is going to come in at? This is supposed to be low ESR. .64. Okay, so I think it's pretty obvious I don't need to do any more tests on the 100 mics. Let's see. I've got some 10s at 63, just normal ones. Closest in here, I don't think there's any 10 at 63. I think there's just 10 at 50. That's alright. Let's grab a 10 at 50. And a brand new, all these caps, I'm checking them against a brand new, by the way. So remember, all the caps in this kit are supposed to be low ESR. And we're at 1 kilohertz now. They're 10 microfarad low ESR cap. 5.87 ohms. Let's see what a normal one comes in at. Oh, how interesting. Again, about half. Yeah, rightio. Let's move up to the other end of the spectrum. Again, this is not low ESR. Actually, you know what? I'm just going to grab one just for shits and gigs. I don't know why I didn't. I wasn't thinking. I don't have any 10 UF caps at the moment that are low ESR in here, but I do have. Oh shit, that's the wrong cap. Sorry. Here we go. 470 at 63. Right. Now I will say their 470 cap, it's a bit more fairly sized, but it's still smaller. Oh, and we've got a normal one here too. So we've got low ESR, you know, actual low ESR, a normal one, and then the Chinese low ESR. Let's see what we got. So the real low ESR 470, 0.04 ohms, right? 0.05. A normal one, 0.08, 0.09. And the Chinese low ESR special. Oh, is that one actually low ESR? Hold on a second. Oh no. What was I thinking of? I forgot there was an extra zero there. Yeah, so we're in 0.5 to 0.08 with a real low ESR. This is got a whole zero missing. What the? What the fuck? What? This hasn't happened before. Kind of a bit concerning. Wires could have snapped off the tip, that's possible. Okay, this is starting to get scary. None of these caps had voltage in them. No. I mean, they're all brand new caps I got out the drawer. What the? Oh no. Boy, that was scary. I thought my LCR meter broke. Right, anyway, where were we? The crap one, it comes in all the way at oh, this is really odd. Someone's at my door. Just give me a moment, sorry. Okay, this video is going to get a lot more interesting now because I just got another delivery. So this is awesome. I've got transistors to check now. And I've been very eagerly waiting these transistors too because I've got amplifiers I want to build. And these are some of my favourite transistors. My two favourite transistors for building amplifiers would have to be the SAP15s and 2SC5200s, 2SA 1943s. I can't think, SAP15s, what's the PNP or NPN counterpart to that? SAP and something else. Oh no, there's SAP15N and SAP15P, that's right. Anyway, I digress. What on earth is going on here with my LCR meter? Probably nothing, you know, I just realised, probably just this shit ass cap. Yeah, it can't read anything at 1 kilohertz. Let's go down to 120 hertz. Wait, is this cap open? I swear, no. The leads aren't bonded inside. There's no way. I literally have to just stick this on my multimeter and the power supply. I can't believe what I'm saying right now. let you guys have a quick look too. Sorry. This is just shocking. I know I'm touching the leads, it's 470 mic, it's not going to affect the reading. I know my ASR meter does have a upper limit somewhere. It could be around here. That might be what the problem is. I do have a manual for it. The problem with that is I have manuals for a lot of things. Where is it? It's got to be in here. Jeez, how much crap have I bought? You realise how much crap you've bought when you start going through your manuals. There's just so many. Here it is. Don't tell me this is all in Chinese. UF. Oh no, 2000 UF. But what, it only does it at 1 kilohertz? We'll try that. Let's just start back at the beginning here. 0.05 for a real low ESR cap. Normal one comes in at 0.09. I think it was 0.08. Yeah, leads weren't making good contact. 0.09, 0.08. What does this one do? Yeah, so these are not low ESR capacitors by any means. No matter, you know, like, God, some of them don't even match, you know, a normal capacitor in terms of ESR. Basically what I'm trying to say is these are actually shit capacitors. I'm certainly only going to be using these where, you know, a normal capacitor goes. I'm going to be doing some voltage testing. We'll do that now too. 50 volt, 10 UF. Just trying to make sure I put them back where they come, otherwise I'll have a lot of sorting to do. But I think that's enough saying on the LCR meter. We're not, you know, we've looked at 10s, 100s, 470s. I don't really need to measure the whole thing. It's literally just the two brands in there, you know. Don't buy this. Do not buy this unless you just want some cheap, dubious quality capacitors. Like it's shit quality by normal capacitor standards, you know. So I guess, you know, if you want to buy it, you could maybe use the 22 mics, where you might use a 10 mic and you'll be okay. You can use it, but it's not. This is not quality by any means. I got to go up the road for a sec, but you know what? I've just thought I want to do breakdown voltage testing on this. So I'm going to stop the video again. I'm going to go up the road, do what I've got to do, come back, and we'll do some breakdown tests on them and see what voltage they handle up to. And I'm not talking about with the Chinese breakdown tester thing. I'm talking about on a power supply. You know, I can put power supplies in series. I can make pretty decent voltages in here, so we can very easily test these. So we'll do that in a minute. And then also when I get back, where did I just put my delivery? Oh, I just received a whole load of 2SA 1943s and 2SC 5200s. So we're going to be checking them for breakdown voltage and HFE. Just a quick test, just a quick sanity check before I go and stick them in an amp build, you know. Obviously when I go and build an output stage, I'm going to match them and all that, but, you know, before I go and even put these away, I want to know that they seem real, basically speaking. But I'll leave this off to the side for now because we're going to do the voltage test on this and then we'll check them out. Alright, I'll be back very soon. It'll be a second for you guys. For me, it'll take about half an hour. Alright, so what I've done is I've put this supply in series. I've put my fluke here so that you can see the added voltage of both sides that we're putting across the capacitor. Start with the 10 microfarad, low ESR. That's hooked up. I'm just going to hold it like that so that if it goes pop I don't end up with crap in my eyes. You guys can see that screen anyway. Who cares, I'll just leave it there, it'll be alright. Forgot to check the voltage on it, that might help. 50 volts. Well, we can definitely source that here. Just turn the current up a little bit so there's like half an amp or an amp, so it is fun. If it decides to pop, it's always good when things are fun. And let's not be patient or anything like that, no. Well, it's going to have some tolerance on it, so let's go up. Yeah, let's leave it there. Let's just let it soak for a bit. Trust me, I'm as surprised as you guys are right now. I've not had very good experience with cheap electrolytic caps in the past. I've bought some that didn't make it to 16 volts that were labelled 35 and 50, so this is promising. No, that's not on the edge of breaking down and drawing a milliamp, that's just the power supply. You see. That's really good. Alright. That's the 10. Oh, you know what else I might pay attention to? There's two brands of caps in here. Yeah, right. This 10 was a Chenzing, CHENXING, with vent spilled correctly. Now I'm going to try the 100 mic at 63 volt. This is a Chong X brand. I think we all know about Chong X enough. If you don't, just type in Chong X on YouTube. You should be able to find enough videos. They don't have a good reputation. But I think even Chong X is literally made by 100 different Asian manufacturers, because I've seen some of these that don't handle their voltage and some that do, so I don't know what to say. I've also seen some with the vent spilling correct and some incorrect, so yeah, who knows who's making what, but anyway. This is a 63 volt cap, by the way. Now, if I want to get cheeky, I can bring in some more power. That isn't a problem. What do you reckon? You reckon we should do that? I wouldn't even bother sticking the 1 amp supply in series with it. Wait, can you see that? Yeah. But my one, which can source 5 amps and doesn't have any constant current circuitry in it at the moment, so it's just constant voltage, I can stick that in series with it. That'll be fine. Let's do that. What's wrong here? Oh, my panel meter's not hooked up. Let me just stick these two wires together in my power supply. Right, my panel meter's hooked up. Turn that back on. Maybe get these wires out of it that are just hanging inside. Right, that's better. Oh, it's on still. That's not good. Oh well, I didn't blow it up, it's all good. So I'm just waiting for my power supply to start up. this will take time. It's basically time delayed until it gets to 250 millivolts, at which time all the reference circuits and regulatory circuitry and everything's come up to at least a stable temperature, which I thereby deem the supply to be stable at. You just have to wait. This is done with an RC time constant delay circuit, if you're wondering how I achieved it. It's nothing special, but it does the trick. It stops you from trying to set a voltage before the supply is stable. That's why I did that. I'll just grab a couple more leads here too. There we go. There's a whole 30 volts here, so we've still got plenty more that we can add. There's no worries about that. Alright, turn the camera back around for you guys. What have I done? Oh, I need to trace my wires out. I think I've done something silly here. Oh. Wait, what? Oh, God. Oh, that's right. These two are already in series, so we've got positive coming out of there. Yeah, right, that wouldn't have been nice. I thought I did something a bit silly. I did. Something very silly. Alright. What I'll do is I'll turn mine up a bit. How's that? 75 volts. Can you still see that? I don't know if you can. 75 volts. Alright. And then I'll just use this to bring it back down. We'll hook this cap back on. Right. 63 volt cap. Well, that's an extra 10 volts on it. Which I don't even know what percentage tolerance these are. That could even be more than what its tolerance rating is. So I'm happy with that. I'm actually quite shocked, to be honest. Wow. Okay. Quite surprising. Do I dare to do this with the 470 mic? That's going to be a bloody big explosion if it goes off, I tell you. I could turn the current limit, all the way down. But it's not fun then, is it? And if it's not fun, well, it's not good enough, is it? I think what I'll do is I'll turn my supply down. I'll wind this up first. That way I can then stand all the way over here and turn this one up. And if shit hits the fan, I can just pull cable out, thus making everything open circuit. So that's perfectly fine from where I am. Let's go. pretty promising. I'm trying to be cautious. I've got one hand on a cable ready to rip it out, so as soon as I see the current start going up. But to be honest, I've got the current set high enough that it's going to rise that quickly, and suddenly it's probably just going to go bang anyway. Well, it's holding 75 volts, so I'm pretty happy. Alright, I'll back that back down. Well, I'm not going to sit there and voltage test every single one. I'm just going to say, look, are they capacitors? Yes, they are capacitors. Do they meet their voltage rating? Yes, they meet their voltage rating. Do they meet their capacitance in terms of tolerance? Well, yeah, they're only like 5 or 10% spec caps, and yeah, the capacitance rating is a bit shy for some of them. The larger values I've noticed are smaller. What I'll do is I'll just bring you guys back over here. Let me just wind a couple of things down so I don't cause myself trouble in the future. I'll just pause this and get the phone back over to my desk. Right, so back over at the desk. What am I doing? Alright. Actually, I've just grabbed the 470 here. So, yeah. I'm not sure what tolerance they are, but they're not great caps, as you can see. The ESR's shit. And the capacitance is, under. As you go up, I think they're 10% caps, so I think it does fall within value just, but, it's on the lower end, I've got expensive, brand name caps that are 10%, and the 100 mic still test at like 95 to 100 mic, even though they're 10%, like that. These are, this is a 330 coming in at 286, so, it's, like I said, are they capacitors? Yes. Do they work? Yes. Are they going to blow up because of voltage ratings? No. Are they quality capacitors? No. Are they low ESR capacitors? No. Are they even decent ESR capacitors? No. But for the price, like I said, if you want 10 mic, you can always just use a 22. It's going to have lower ESR, higher value. It's going to work out, You can make do with it in most applications. So I wouldn't say don't buy it, because yeah, you can certainly use it, but just be careful going by the values and what you expect the ESR to actually be, because that's where you're going to have problems. They are under spec and they're crappy tolerance. So when you put the two things together, yeah. And you don't know what the chemistry is in it too. So, the thing with electrolytic capacitors is there's a lot of different types of chemistries, different types of insulators, all sorts of different things that go into making up a capacitor, and it gives it different properties. You also don't know how they're going to behave over frequency. Are they going to... We could really talk about this for a long time, Just be careful with these. That's the point I'm getting at. As you've seen, the ESR is shoddy as, and the capacitance values are low. So, But I think the whole box cost me like $16 or something. It was cheap. It wasn't much, So you can't complain for the price, like I said. It is what it is. Fuck it, I just short it. Shouldn't really do that. So what I'm thinking of doing now, I think I might actually just leave this video off here and just upload this just on capacitors, because I've got these transistors to test too. I might as well just do it quickly in this video too. It's only going to take a moment. I think these come in an HFE of R, O and Y from memory. This is only off of memory and these are O's, so they should be somewhere in the middle. Let me just get a data sheet so I can tell you proper specs. Ballpark figures, you know. Should have got this up in advance, my apologies. TSC 5200. Okay. Now, something I've got to point out about, oh, what did my computer just do? What the hell? My computer's just gone absolutely nuts and just opened a million things at once. I don't even know what happened. Anyway. It's like I've got a stuck key. I have to look into that. Alright, I'm just scrolling down the data sheet to have a look at the gain categories first. I think they're R, O and Y, but it could be something else. Doesn't even say in this data sheet. I do remember the last time I was building an amp with these, I had the exact same problem and I had to download different data sheets. That's where you got to be careful with these too, because 2SC5200s, there's the old 2SC5200s, the newer 2SC5200s, and then there's also TTC5200s and TTA 1943s. And well, they all spec slightly differently in terms of collector current and I know the output capacitance changes between the older ones and the newer ones of these ones. I remember that. And I remember some of them are 17 amp and some are 15 amp. I think they're all 230 volt. But okay, I can't find what I'm looking for in this data sheet. I'm just going to open a different one. And that turns out to be the same data sheet. Wonderful. Wonderful. Huh. Try this one. I've got 4 different data sheets here. Okay, this is a different brand. Let's see. I might have to pause the video because I can't seem to find the 3 HFE categories. So you put a little letter on the transistor for those of you that don't know what I'm talking about. In this case, it's an O. I think these are R, O, and Y. R being the lowest HFE category, O the middle, and Y the highest. I just can't remember. It's been too long since I built my last amp with them. Sorry guys. Let me just open this last data sheet. No. I don't know. I seem to have misplaced the old data sheet that I had. I have to look into that too. Well, it says on the data sheet they've got a DC current gain minimum 80, max 160. Actually with a smaller collector and base, sorry, bigger collector current, but a smaller, oh no, one's a saturated test, okay. So we've got between 35 and 160. Realistically between 80 and 160 HFE. From memory, they're usually around the 100 area, the O's, and the Y's are somewhere above 120, I think. I think the Y's off memory used to be 120 to 160. The O's were like 90 to 120, something like that. It's been too long. I'm sorry I couldn't find that in the data sheet. Let me just double check the pin out too before I go and stick some voltage across here. Geez, what's going on with these data sheets? 1, 2, 3. Oh, okay. 2 is the collector, 3 is the emitter, right? Let's have some more fun. This one's a 5200. You know what I haven't even done yet? This will give us a very good indication of the size of the die in here. What I mean by that is it a little die out of a 2N2222A in a huge package, or is it a big power device in there? I find that a little suspicious, but I can't remember. Like I said, I thought 120. No, actually I remember now. Yeah, no, that is probably around about right for the O batch. Yeah, that's right. I remember, because I remember the older ones, the gain was lower on them, and the newer batches that they made were towards the higher end of their, like, what do you call it? The gain, like the gains, ROY or something like that, and like each category is between, say, 60 and 80, 80 and 120, 120 and 160, for example. I remember the older ones from, I don't know, early 2000s, 90s maybe, measured lower in gain, and the newer ones I've come across were higher, but okay, that's a bit more believable. I think these are actually legit. We'll know soon, because I'll be doing tests with them. I'm not going to do too many tests. I might put my function generator into it and put it on the scope and put some current across it and have a look what it does and compare it to the data sheet. I might also do a current test between collector and emitter, Oh, these are all coming out around 120. I mean, I'm not complaining. Let's hope that these are all genuine. They're just really tightly matched. That would be really nice for me. For those that are wondering why I bought them this way off of AliExpress, last time I had to order these, I wanted them, the Y batch, and I wanted them all matched. So I called up DigiKey on the phone and I requested that. I got it. I had to wait 52 weeks. 52 weeks to build my amplifier. So I thought I'd just shoot my luck this time. I actually ordered a few batches of these. So these are all 5200s. And these are all 1943s. 2SC, 2SA. And I've actually ordered a few batches. So I ordered a bigger amount from this seller, I think 40 of each. And then there's another seller that they just had like matched pairs or something. I probably got about 10 of each or something like that, or 20 of each from them. I think maybe 1 or 2 other sellers, I can't remember. I don't know why I put all those back in there. Let's have a look at the 2SA 1943s. Appear to be exactly the same batch and everything. That always makes me suspicious, but you never know. Got a bad habit of just turning that on. I forget that it tests on power up. I will say, I don't remember exactly what the gain could be. O could end at 130 or 140 or something, It might be perfectly legit. Well, let's do a voltage breakdown test, eh? I'm just going to pause the video because I just want to put this on my meter and just do a quick current and voltage measurement. I just want to see how accurate the display is so I can actually tell you guys what's going on. Actually, I think I'll just use my meter. I'm going to pause the video and reset up here so you guys can get a better view of what's happening. Alright, so I think this is a more fair way of doing it. I'm just going to wind the current up as much as it can supply. It's about 1 milliamp, to be honest. I've done some tests already. Let's just go for it, I guess. I'll just move this base pin over just a little bit more. Should be fine, but... So, like I said, these are supposed to have a collectometer voltage of 230 volts. So let's see. This is going to be tricky. Bloody tricky. Oh, it's broken down already. Really? Wow. Really? I just want to say something. I just find that not good news. Upsetting is the word I'm thinking of. Find it to be disappointing. I've just tied the base to the emitter for those that are wondering. Ah, there you go. My bad, people. My bad. I guess transistor was turned on a little bit. All good. I can still go high. That hasn't broken down, and I don't want to break it down. I don't want to break these things down. I'm happy with that. Yeah. Okay. That's fine. This thing also, I've got to say, the output, it's not pure DC. It's very noisy and it's pulsed. So, you know, yeah, who knows the effects it could have on a transistor with the base pin just floating. I'm pretty sure you're supposed to measure them floating. But in my mind, it doesn't really make sense. So leave in the comments. Tell me what you guys think. Or, you know, if you know accurately, because I haven't Googled this. This is just me. This is just my own thinking on this, you know. I would imagine with the base floating, that's how you're supposed to test it. But there again, charge can build up literally just from the air on the base then. So that leads me to believe that maybe this is actually the best way to do it. Kind of makes sense why they've supplied the lead too, so you can turn devices off. Yeah, leave it in the comments. Tell me what you think. I'm obviously going to go have a Google of this myself and educate myself, but feel free to educate me. I'll do this one more time, and then we'll try the other one. Oh, wow. Alright, let's not do that again. I'll just put this on the component tester very quickly and just make sure it's still got its gain and everything. Hasn't, you know, started to break it down somehow. Although this ain't going to show how it behaves. I've done it again. This isn't going to show how it behaves when it's under voltage, but still. All this is going to show really is if the base junction's changed and it's lost gain. Which it doesn't seem to have, and why would it? Because the base wasn't hooked up to high voltage, so. Yeah, that's a hard call to make. Honestly, that could be damaged internally, but I don't think it is. I'll know when one of my amplifiers lets out the magic smoke, won't I? Oh, fuck. Hey! Shit. No fighting. Hey! You guys are family before the kittens go in. Pat, come on. That's Junior, come on. Junior, you too. Mate. You're being just as much of a shit stirrer. Yeah, that's what I mean. Ever since one of my cats had 3 kittens, it's been really weird. One of the other cats tried to kind of like parent the kittens and steal the kittens from the actual cat's mum. There's only 3 females out of all my cats that are not desexed too. Let me just point that out. And all the males are. This was an outside cat that got one of my cats pregnant that I actually rescued and it escaped. But anyway, yeah, like, so after my cat had kittens, the other cat tried to sort of foster the kittens, even though they weren't hers. And now she's just running around trying to kill all my cats that she's lived with for like 7 years now. So I don't know what to do. I can't give my cat away. I've had it for 7 years. It's part of the family. It's just, yeah, it's not good. Anyway, let's do the same thing with this. Obviously, I'm going to do this with the voltage going in the reverse direction. I'll just splay the pins out a little bit again. I'm not worried about it arcing over at these voltages. I just don't want to move and the clips kind of touch each other, because as I pointed out in the other video, I've already had to fix this thing since buying it because the current sense resistor just goes open in it, which isn't fun. Might just leave that there. Yeah, that'll do. Alright, can you see everything up? Cool. What? Oh, I'm a freaking idiot. Did I really do that? You can't blame me. I was looking at the colours and not thinking about what I was doing. Jeez. Right. Let's go again. You reckon I should get another meter and put it in series so we can actually have a look at the current flow? You reckon it's worth it? I wonder. Nah, I think it's alright. I think if they're holding up to what they seem to be holding up to, that they're going to be fine. I don't want to go higher. Like I said, I don't want to break them. They seem... They're going to be in an amplifier that has like plus minus 65 volt rails-ish. So I'm not worried. I mean, that's not how I think anyway. Let me say, like, if they're fake, I would have a problem with it no matter what voltage the device I'm putting them in runs at, you know? Like, I want my parts to be legit, but yeah, they're going to be fine. They seem pretty legit so far. Obviously, as I start doing work with them, you know, I'll let you guys know if something's not right. And when I do more tests with them, I've got TTC 5200s, TTA 1943s. I've got some old 2SC 5200s. That's actually literally what's right there on the heatsink. I know you can barely see it. One sec. those are 2SC5200s, but the old ones, which is why I use them for my power supply, because they're virtually indestructible. Yeah, so I can do some comparisons, like I can put signals through them and have a look at transition frequency and stuff like that on my scope with my function gen, and I can compare them to other ones that I have. So if I find anything odd then, or I end up just, you know, spending too much time on it and I think it will make a good video, I'll end up doing a video on that too. To be honest, I might not even bother. I might just go and VBE match them and gain match them and start using them in amp builds. I don't know yet, but you guys will know what I do, so don't worry, you won't miss out. Alright, well that's all I wanted to cover in this video. I just really wanted to see if they seem to be legit, which they do, and I wanted to go over those capacitors. The capacitor kit, by the way, it's from AliExpress, I'm pretty sure. I'm like, yeah, no, it was from AliExpress. And I'll just grab it one more time just so everyone can get a look at it, because it looks pretty much like this in the display picture, except you don't see this, you just see all the green capacitors, and it's labeled like that in the listing, 925 pieces, 36 values, and it's really cheap. Just look out for that, you know, be mindful of it. Like I said, they are capacitors, you can use them, but don't expect them to be, you know, as good as you might think that they might be. Alright, well, that's all for now. You know what, there was one more thing that arrived today, and you're not going to believe how bloody pissed I am. You know those panel meters that I had that were oscillating, and it took all of that to make them shut up? Well, I ordered these other ones that were 4-wire, and in the listing there's a chip that's about that long on this end of the board, the micro in the middle. It's a completely different board is what I'm getting at in the picture, right? You're not going to believe what they sent me. This is how the 3-wire ones come before I modified it, just if you're wondering. They sent me, hold on, let me get one out the packet because you can't see there's a label over it. The same fucking board with 2 plugs on it. Sorry about my language, but I'm so pissed. I bought 4 of them. 4, expecting, because in the picture you can clearly see there's an extra op amp on there or something. You know, there's some sort of chip on the board. There's an extra chip that provides isolation, and it's true 4-wire measurement. That's what's in the picture on the product description. It talks about it. It even has a different like measuring accuracy and everything. Like you can tell it's a different meter. So I've ordered them, and all they did was sent me these ones just with 2 extra plugs on them. If you don't believe me, go on eBay and type in 0 to 33.000 volt DC panel meter and just have a look at them all. Type in 4-wire and have a look at all the different listings and scroll through the pictures and compare the boards to this board that's got the voltage regulator in the corner, the micro in the middle, and this little thing that says key and the JTAG looking connector. It's not, I'm just saying, like you can compare the boards and you can see that they're different. Anyway, I got ripped off. So I've literally just got a whole load of the same meter, basically. Wonderful. Oh well. So I don't know, because I was actually waiting on the new ones to come. I was going to try the new ones in my power supply and see if they didn't have that noise problem. If they didn't, I was going to use them. Now I've got so many of these, I guess we're just going to end up building buffer circuitry for it, because I'm done waiting. I'm not waiting any longer. I've got tons of these. I know how to trim the precision on them. We've done a video on that. I'm just going to use these. I'm just going to have to build buffer circuitry for it. But yeah, that's just a quick update on what's going on with the panel meters. I've actually incidentally got everything back on the desk here so I can continue working on this build whilst I'm waiting for the transistors for the, what do you call it? The Yamaha mixer, the AMX 512 SC. So, and they'll be here. I think it was 7 to 15 days or 5 to 7 days. I can't remember how long it said it was going to be, but they're on the way too. I don't know if I should say this in this video. Yeah, who cares? Spoiler alert. We're going to be having a look on the switching power board in that Yamaha mixer, because I was thinking about it. Those digital logic level transistors, the four that are open, that are on the amp board, they are obviously, let me just grab the amp board so I can show you why I say this. Two are right there, and you can literally see their base or one of their pins going off to this connector that goes to the power supply, and the other two are just there, that one and that one. So they go straight back to the power board, I'm pretty sure. We're going to be checking the power supply, all the circuitry on it, like the DC protect and the clip protect, where all the signals come into it that can force it into shutdown and stuff like that. We're going to be checking all the transistors around that section just to make sure none of those are blown too, because I find it hard to believe that there's 4 blown transistors in there and nothing else is blown, right? It doesn't usually work like that. But in saying that, remember how I found all this dust in the amplifier? Well, I found this spillage inside it too, so chances are actually those 4 transistors and maybe something on the power board, who knows, is all that's wrong, because liquid just went into it and shorted something when it was on, and that's it. Who knows? I just thought I'd let you guys know about that. So that's what's happening. Anyway, I'll leave off here. I'll upload this. I've got some stuff to do. I don't know if I'm going to get any more work done in here tonight. If I do, well, I guess there'll be another video. Alright, thanks for watching. Take care everybody, and I'll see you in the next one. Watch out for dubious components.